Thank you guys. Thanks for joining the call at 9 p.m. and I can understand your noise level. If you are joining the call at 9 p.m. and that too on Sunday. So all the best. Let's start with a revision. We'll try to revise some of the concepts that we learned yesterday, and we'll today we'll cover all the topics which are pending to complete DP 900 Azure Data Fundamentals. Okay, so these are some of the things that we covered. Again, I'll repeat. In this session, I'm going to cover Azure storage for non-relational data. And when we talk about non-relational data, then we also need to discuss about Azure Cosmos DB, right? This is something that provides multiple APIs work with non-relational database systems. So Azure Cosmos DB is non-relational database, which is basically to serve four different kinds of non-relational database. So hence it offers you four different APIs. I mean four different non-relational DBs such as key value pairs or graph DB or document DB like that. So yesterday also we covered the practical aspects. How do we create certain services in Azure? So you need to access Azure portal, wherein let's say you want to create SQL database, then how you can create those services. So we already discussed all those things, and hence today we will cover the remaining topics, which is related to non-relational. And at the end, we are going to cover uh, data visualization, which is required to understand in terms of Azure what all services are being offered by Azure Microsoft. Right? So in non-relational data, we covered why there is a need for non-relational database systems, because all the systems are not able to follow the rigid structure of relational database systems, right? Because we need to store those data in rows and columns, and again we need a schema which is a definite pattern, a definite uh, data type, and all those rigid structures, right? So if there is a need for something different from a rigid structure, then there is a need for some different database, right? There's need for different systems. So hence there is something called NoSQL, which takes care of this non-rigid structure. Okay, so in this case also, as we covered storage part as well as database part, right? So storage part, some of the things will cover as part of what are the different offerings from Azure. So we discovered this one, right? We learned Azure blob storage, what it is. We covered that we can create multiple blobs and store it. Folder created in Azure blob storage is virtual, it's not real, so you cannot perform any folder level operations like searching or filtering. So those will not be applicable here. And then we learned about different blob storage, which is basically block blobs, page blobs, append blobs. Okay, now today we are going to start with let's freshly start with the blob storage access tiers. So access tiers is it's very important whenever you work with any cloud provider or any cloud systems. Then they do provide some kind of different levels of storage or different tiers of storage, such as in this case Azure provides three different tiers: hot tier, cool tier, archive tier. And in this case, as the name itself suggests, hot air means something which is hot, right? Something which is very fresh, right? So if you cook food in the kitchen, then it will obviously be, if it's a fresh, then it will be hot, right? So hence it's a hot tier, which is basically the default one. It is used to store the frequently accessed data. So whenever you create or upload any new blobs or any new, or let's say report or files, then it goes to hot tier, okay, which is the default one. So whenever you try to upload any files, it will always go to hot tier, which is it provides high performance. And then comes the cool tier. Cool tier has a bit lower performance as compared to hot tier, but also the charges will be less, right? So in case there is something that you can manage the low performance, then you will definitely want to use cool tier. And basically the use, when do you use this cool tier? When you have such files which are not accessed frequently, uh, which can, and in case you need to access those files frequently, then obviously you will have to migrate to hot tier, or you will want to migrate it to hot tier so that you get a good performance over that, right? And then comes archive tier. So archive tier is something which is available at the lowest cost, but the thing is it will also have the highest latency. Okay, so the blobs or the files that you store in this archive tier, it's in offline stage. That means you cannot access it, right? So it's just for the archival purpose. In case you need to access those files that you have stored in the archive storage, then you will have to put it back to either cool tier or hot tier. So this process of putting it back to cool or hot tier is referred as hydration process. So in hydration process, you must change the level of tier, right? Either it's cool or hot. You cannot access the file which is stored in archive tier. But yeah, in case you just need to save your file and you're not bothered about accessing, maybe you need it after a year or so, or you are just archiving it for some compliance purpose. Let's say some bank or RBI needs those files so that you can show it to them when audit comes, or as part of certain compliance. You will store it in your archival system, and whenever it is required by other third parties or your team, you can move it to cool tier or hot tier, and then you will be able to access it. But uh, in case if you just to store it, you better archive it and store it in archive tier because it will have the lowest storage cost. Okay, so that's the difference between all the three levels of storage, right? The hot tier, cool tier, and archive tier. In other services which are offered by other vendors like AWS or GCP, we do have different levels of tier, which is very very similar to this one, right? Hot tier or soft or something like that, which you will see when you read about or work with other cloud systems such as GCP or AWS. But the thing to understand is we'll get different levels. So some of the tier will be low cost, some of the tiers will be high cost or high performance. So it will be a common, in fact, across all the organizations. And then we'll discuss about data lake storage. So this is something wherein it is used to store blobs, which is basically uh, larger files, right? Large files will be able to store it in data lake storage gen 2, but it doesn't mean that you won't be able to store smaller files. But in fact all these storages are made for big data systems, right? So it is understood or known that the default file size will be a bit larger than the normal file size. So Azure Data Lake Gen 2 is the newer version. So earlier the version was Gen 1, which is basically a separate service. It has nothing to do with Cloud or Storage Gen 2, which Gen 1 provides API, and using API, if you have stored your blobs or some of the files in Data Lake Store Gen 1, then you will be able to access it via API. You don't need to know further about it. But yeah, Storage Lake Gen 2 is the newer version, and it is widely being used by most of the organizations nowadays. So this is one of the storage being provided by Azure. What's the benefit of using it is in Blob, as you saw, you don't have option to create directory, right? You will be able to create virtual directly, but it's basically the file name itself that gets prepended, right? That acts as a prefix. But in this case, you'll be able to create directory, similar to how you organize your files in your local systems. You create folders and subfolders, and then you organize your files. You save in different folders based on your requirement. Similarly, we can create this hierarchical namespace. We can create different directories inside blob container, and and we can store different files, required files. And another option is, even if you have created this blob storage, you will be able to convert it to data lake storage gen 2, but this conversion or the process is just one way. So when you convert it to hierarchical namespace or data storage Gen 2, then you won't be able to convert it back to blob storage. So that thing you need to remember. It may be asked in the exam, or also for uh, when you start working with Azure, then it is very important. So once you create it or convert it to blob uh, data lake storage Gen 2, then you won't be able to convert it back to blob storage, normal blob storage. So this is one way process. So use, of course, whenever you need to store large data, big or huge volumes of data, right? Then definitely you are going to use this blob container, which is data lake storage Gen 2. And one thing I'd like to put emphasis on, hierarchical namespace, right? So the difference between blob storage and this storage Gen 2 is there is an option in Azure portal that you'll get to enable this hierarchical namespace. So when you just click it as hierarchical namespace, you check this box, then it gets converted to storage like Gen 2. And when you don't click on any part, then it's blob storage. Okay, so that's the difference. Only the hierarchical namespace is enabled in data lake storage Gen 2. And then we'll discuss Azure files, which is basically used to store different key value pairs. So don't get it confused with the normal. Okay, this is different. We will see that Azure table. So Azure table is something you might get confused with the normal tables, but when we discuss about the Azure table, which is the next that you're going to discuss, we'll discuss more about it. This file share is something similar to the network storage. So in your organization, you might have certain shared network storage or shared folder which you are sharing with your teams or different teams in your organization. So this is very much similar to that. In case you want to share the files or the large files with the other teams, then you would definitely want to use Azure file share. In this case, you will have to just similarly you create these Azure files and you'll be able to share it across different teams. So a single storage account can share up to 100 TB. Okay, there must be certain limitations on each and every storage part. So in this case, whenever you create Azure files, you have limitation of 100 terabytes of data. You won't be able to store more than 100 terabytes of data in a single storage account. Okay, and the maximum size of a single file that you will be able to store in Azure files is 1 terabyte. Okay, so it's a big chunk, right? I mean, usually files or the big data files that you work with will be like 200 GB or 500 GB, but 1 TB is it's big enough, and still you will be able to share it. And the maximum size of that single storage account, it will be able to 100. It will be able to save up to 100 terabytes of data. That means if you have files of 1 TB, you will be able to store hundreds of files of 4 TB. And in fact, you have also the option of setting quotas or the limit, right? It's not that the maximum file size of a single file that you want to store in Azure file share will be 1 TB. You can reduce it further. If you want to set like 200 GB or 500 GB as the maximum size, you can definitely limit that size. You have that option. You can configure it in Azure portal. And one more thing to note down here or remember, in fact, is you can, I mean, the concurrent connections that can connect with this Azure files is 2000. Okay, so it supports 2000 concurrent connections. So 2000 users will be able to work on a single file at the same time. Okay. How do you copy these files, this kind of files to Azure file storage? So there are two ways. One is Azure portal, right? So Azure portal, it's an online web-based portal. You have option, you just click on upload and then you will get to share or select the files from your local system. And the another is a copy. This is the utility which is provided by Microsoft Azure, and you can use it to copy these files to Azure as well. And in the last uh, blob storage part, we saw that there are three different levels or three different tiers when we work with the storage, right? In this case, for the Azure files, we only have two tiers. One is standard and the second one is premier. So standard is hard disk. You can consider as if you are working on your laptop, you might have this normal hard disk, right? Or you may also have SSD. So SSD is something which is premier, right? That will offer a bit better performance, and hard disk will have a bit lower performance, right? So that's the difference. It has only got two tiers. One is standard, which is based on the hard disk, and another one is premium, which is based on SSD. Now we'll discuss about Azure tables. So what I was telling is Azure tables don't get confused with the normal DB tables, because we discussed about SQL DB tables, different kinds of SQL pools and all, right? Those are different. You consider it as a storage, right? Similar to how we store files. It is just that you will be able to store your records in rows and columns, but it will be classified or come under storage account itself. Okay, so this is kind of tables, but you will be able to store it within the storage account. It will not adhere to relationship models that we see in relational database. So there is no concept of foreign key and all. And when there is no concept of relational things, or it's not database, it just storage account, then you won't be able to create any stored procedures or views or any other database objects, right? Because it's not a database. And also in this case, data is denormalized. Okay, we'll come at this point. I think we will discuss what's normalization and denormalization whenever we work with data. And if the need for the data which will be used for analytical purpose, then it needs to be denormalized. And when the data is basically used for transactional purpose, then it's normalized, right? So there's a difference between normalization and denormalizations from the practical perspective. So in this case, you have the data stored. So one is key and another one is value, and the com- key is comprised of two columns in this case. One is partition key and another one is row key, right? So partition key is something which is basically a kind of classification based on certain partition key. Let's say if you want to divide multiple rows into, or classify different rows into based on a single property, then we will obviously define a partition key such that all the rows with similar structure or with similar properties will be classified in partition key 1, or another different set of rows will be classified to different partitions. So now you will understand what is partition. Okay, this is also very important when you work with distributed storage or cloud storage or big data systems. Then you will often come across this terminology, which is partition. Okay, so partition is nothing but it's a way of grouping related columns, related rows. Okay, so based on a particular key, based on a particular value, right, or a column in this case. So that's basically partition. So whenever you have multiple rows, right, whenever you work with big data system, let's say lakhs of rows will be there, and let's say you have stored products, right? So product will have product type. In this case, we can partition or divide uh, all the rows, divide the entire data into different partitions based on product type. So let's say product type 1 will go to one partition, product type will 2 will go to two partition, second partition, product type 3 will go to third partition, and so on. And each partitions will be independent from each other. There is not, it has nothing to do with, let's say partition 1 has nothing to do with the second partition, partition second has nothing to do with third, and so forth. So in this case, whenever you add any data, so based on the particular partition key, it gets added to the partition, right? So data may grow in case you are adding something new. It can shrink if you remove the data, right? It is similar to what how we work with database systems. It is just that it's a terminology that we use, and in most of distributed systems, we use this partition. Why do we use these systems? Because since we are working with distributed system, we will have multiple nodes. Nodes means machines, right? We will have multiple machines. Some of the machines will have different set of partition. Let's say partition 1 and partition 2. Some of the nodes will have partition 2 and partition 3, so that we divide the data among different nodes, right? We don't keep everything on the same machine, because that's how the distributed system works. And we want to uh, make use of scalable systems. We want to, if we want to add more number of nodes, then obviously we'll have to divide the data, right? And how we divide it? We divide it based on partitions. We create different partitions. So this is what you understand by partition. Okay, so this is another exercise that you need to do. Again, I'm reiterating. So you should create your account in Azure, and then you'll be able to work on these exercises. These are important so that you get the feeling of how do you work with Azure or any cloud systems. How do you create storage? How do you create database? Yesterday, I followed all the steps to create a database, right? How do we create SQL storage, or how do we create SQL database? So similarly, you can work on and create the storage part. You can create a storage lake gen 2. The process and the steps are very uh, easy. So you can directly follow the steps which is mentioned in this document. So you click on it, it will take you to GitHub, which is basically uh, the steps provided by the Microsoft. So you'll be able to follow it. In case you face any difficulties or challenges in following these steps, you can definitely uh, ping me, or I'll let you know, or I'll clarify in case you're facing any challenges. Okay, and next we'll cover Azure Cosmos DB. So whenever you work with non-relational DB, so this is of utmost important, because Azure provides a single Cosmos DB, which is basically used for all the different kinds of non-relational systems. So what are different kinds of non-relational database? One is documents database, graph database, key value tables, and then column family store. Okay, so these are basically four different kinds of non-relational systems, database systems that we have, and it offers services for all these different types of database, non-relational database. Okay, how does it provide the support for all these different kinds of database systems? Via API. Okay, so it has got API, so you will have to use this different API. Let's say if you are working with documents, non-relational database systems, and it's being configured in Cosmos, then you will use document API. If you're working with graph DB, then now you use graph API. Similarly, for the other tools, you will use the respective APIs for key value and column family store. And the plus point of using Azure Cosmos DB is there is no overhead of maintenance, right? Because anyway, this is something which is provided by Microsoft Azure, and you are just using the services, right? You are not trying to create infrastructure. You don't need to take care of operating systems and all. So the virtual or the administrative overhead is at most almost zero. You don't need to maintain those systems. You basically access these database systems via API. In this case also, since it's based on distributed systems, so you will again have partitions, right? So whenever you work with distributed systems, you will always have partitions. Okay, if this term is new to you, just remember, whenever you work with different uh, distributed systems, you will work with partition basically divides the data among different nodes, which is different machines, right? And in fact, this Cosmos DB itself is being used by Microsoft, right? So Microsoft 365 or Azure, this basically use Cosmos DB because it provides you all kinds of it supports different APIs, which is basically to support all different NoSQL database. So whether you're working with Skype or Xbox, in the backend it uses Cosmos DB. Okay, now we'll see different kinds of APIs that is for we have the support from Azure for Cosmos DB. So whenever you work with a Cosmos DB, so you should remember that it doesn't only provide support for NoSQL database, but it also provides support for SQL database as well. Right? In this case, you can create Cosmos DB instance, and while creating the instance, if you want to use PostgreSQL, then you can obviously select PostgreSQL. Right? So that's one of the services provided by Cosmos DB. And apart from that, we saw different database like key value pairs, document DB, which is basically MongoDB, and then Cassandra. So when you try to create a non-relational database systems, in this case, you will be able to select the type of DB or the engine or the database engine that you want to create, whether you want to create relational database systems based on Postgre, or whether you want to create MongoDB, or whether you want to create Apache Cassandra. Everything, these all services are available under Cosmos DB. So these are basically nothing but database engine. So whenever you work with Cosmos DB, just stand these are the database engine that you select when you try to create any service related to Cosmos. Let's see this Cosmos DB for NoSQL. So in this case, what kind of data does this support, right? Cosmos DB for NoSQL. So it doesn't mean that it is it's uh, it means the entire set of NoSQL database, right? No, it is different. All those will be covered and taken care later, but this is particularly for its own Cosmos DB properties, right? Its own Cosmos database or non-relational service. So the non-relational service provided by Azure in Cosmos. So the first one is Cosmos DB for NoSQL, which is different from what we discussed the meaning for, right? So we'll cover all those, but this is separate one. Okay, it's not combination of all different NoSQL database that we discussed right now. It is a particular service for non-relational database systems. So whenever you work with document data, right, it's kind of a JSON, right? So whenever you work or need to store the data in just JSON format, then you may use this Cosmos DB for NoSQL. There is another service that will see what are other options we have for NoSQL database or non-relational database, but in fact this is one of the services provided by Cosmos. So whenever you work with a JSON document format, you can use this Cosmos DB for NoSQL. Okay, so you need to remember this is the format, right? What's the format? It's a JSON format document, and the syntax to query that file or the data that we have stored, it's very much similar to SQL. Okay, in fact you can see, right, select star from, you need to select the tables. Let's say you have stored it in table, and then you just select filter it based on ID, which is joe@gateway.com. So the select query is very much similar to SQL, but the output is different. It's JSON document. And then there is Cosmos DB for MongoDB, right? This is also similar to what we saw earlier, but in this case, data is stored in binary JSON format. Okay, so we have JSON, but it's binary, right? It's converted to binary format. So it supports MongoDB, right? So in case you are working with MongoDB in your current organization, and if you want to move to Azure, you may want to use this Cosmos DB for MongoDB. Okay. So what all services we have? So what are the services that you have or you currently use in your organizations for MongoDB? Or let's say you are working on your personal project on MongoDB, you will be able to use all those services, all those libraries in Cosmos DB as well. So it doesn't differentiate between the MongoDB that we XDB work in our organizations or the MongoDB we have on our personal laptop or we work for our personal projects. So all the libraries are already available. You can use all those libraries. In this case also, the format or the output of the query will be JSON format, right? Because this data itself that we are storing, it's in JSON format, though it's formatted as binary, right? It's binary JSON format, but the output after running the query, it will be of the JSON format and you will be able to read it. And then we have Mongo query language. Earlier we saw that Cosmos DB for NoSQL, we were able to use similar query language which we used in relational DB, relational database systems, right? But in this case, it is different. We are working with MongoDB. MongoDB will have its own syntax, its own structure. So in this case, it's called MQL, which is MongoDB query language. It's based on object-oriented syntax, right? So you will have object, you will create instance, and then you will use different functions, right? So in this case, find is different methods of products, right? And you pass parameter, let's say you want to filter out or see the output for that particular id, then you execute this query and then the output will be in format of JSON. PostgreSQL, it's another service provided by Cosmos DB. In this case, whenever you are working with PostgreSQL, then you will be able to create it in Cosmos DB as well. Okay, so what was the other service that we learned for the PostgreSQL? There was one open source database, right? Open source database, we when we discussed all those, in fact there were three different open source database that it supports, right? MariaDB or MySQL and then PostgreSQL. Similarly, for Cosmos DB also we have one, we have support for PostgreSQL because it's basically kind of hybrid database, right? It's relational as well as non-relational, so it provides support for PostgreSQL as well. What's the syntax? Syntax is very much similar to SQL, right? In this case, PostgreSQL will have different, a bit different syntax, but it's basically the SQL that we use. Output will be similar to SQL. Again, rows and columns. It won't be in JSON format. And then we have Cosmos DB for table. Okay. So this is also similar to what we saw in storage part, right? We have tables wherein we store key and value. So whenever you see this table terminology as table, let's say Azure table and something, then you just infer or remember that it is some, it is talking about key value pair, right? So in this case also, when it says what Cosmos DB for table, so we work with key value tables. Okay, it is very much similar to Azure table storage that we saw in our previous slides. But one thing to note down here is the performance. It offers better performance than the Azure table storage. Okay, because uh, uh, when you work with the Cosmos DB, it's one of the most trusted platform, or the DB provided by Azure, which basically they use it for their own purpose as well. In fact, it support Azure services also, right? In the back end, they use this Cosmos DB for Azure or Microsoft 365 that we saw all those different products that Microsoft has. So how do you access the data? You can access the data using API, right? You have this endpoint, you will have this URL, and there you provide the partition key, which is basically a part of your key, right? Key contains two things for the table. One is partition key, another one is row key. So in this case also, we need to provide partition key and row key. This is basically what we need to understand in terms of the Cosmos DB. What are different offerings of Cosmos DB? We don't need to go in detail. We just need to understand the different offerings, like Cosmos DB for PostgreSQL, Cosmos DB for NoSQL, Cosmos DB for Mongo, Cosmos DB for Cassandra, all those things, right? On the high level, what it does and what's the offering, right? What can we do using this Microsoft Cosmos DB and all? What are all the different data services related to Cosmos DB or in fact Azure? That's what we learn in DP 900. And then this is again Cosmos DB for Apache Cassandra, which is one of the NoSQL database. But in this case also, the syntax is based on SQL. Okay, and we already saw Cassandra is column family storage structure. What do you mean by column family storage structure? Let's say you're working with data which has, let's say you need to store the address. So address can further be subdivided, right? Address is family, and address can further be subdivided into, let's say, street, city, or state, pin code. It can further be subdivided, right? But as a family, you will store it in address, right? That's the column family, but it will have different columns like street or state or city, all those things. So this is basically what you understand with column family storage. And you just remember Cassandra supports SQL syntax. Okay, the only thing which is based on NoSQL is you just need to remember Mongo, right? MongoDB will have different syntax. Let's revise this. This will have different syntax in this case, right? So this is based on object oriented, and whenever you work with the table Azure table, that will be again will have different way of accessing it, which is basically using API. You will get an endpoint and then you will access it via URL. These two things, right? For table, and then for MongoDB syntax will be different, and for the rest it will be SQL syntax. And then comes Cosmos DB for Apache Gremlin, which is again one of non-relational database systems. Whenever we work with graph structure, right? Whenever you need to store the relationship between two different entities, then we can work with Apache Gremlin, right? You can store those kind of relationships and nodes or edges in Apache Gremlin. So this is how it works, right? So you will store, let's say, two different entities, Bain and Sue, or hardware, right? What's the relationship? So Bain reports to Sue, or Sue works in hardware department, and then Bain also works in hardware department. So this is the relationship between all these different entities, right? So you connect different nodes. The round ones, what you see, the circles, right? Those are nodes, and then these are the edges or connect. You connect two different nodes using the edges. What's the syntax? So syntax is a bit complex or a bit different for this Apache Gremlin. So in this case, whenever you want to add vertices, right? So in this case, you will have to use different syntax for Apache Gremlin. It's not similar to what we saw earlier for SQL or non-relational DB. It has got different properties. So you don't need to go in detail. You just understand something like these are the different functions kind of thing that you access. So let's say G database, and then you are adding G dot, I mean table, and then you are adding into G dot. Whenever you need to add any new employee, you will say add V, and then employee table basically. And then what's the property that you want to add or save? ID is equal to 3. The first name is Alice, and then all those things, right? And the relationship also, ages, you add edges, right? Vertices and edges. V is vertices, E is edges. Edges basically defines the relationship that you want to store. And how do you access it? Okay, G dot V, basically the vertices. It will provide you the output if you want to filter it by any ID. Right? You don't need to go it in detail. Just and this is the format how we access Cosmos DB for Apache Gremlin or graph structure. Again, we have size for this Cosmos DB, so you can access this after the session is over. You can go ahead and then access all those exercises and do it. And in case you face any challenge, then let me know. I'll help you with these exercises. So that's the end of part 3. We need to cover part 4 as well, which we are going to cover it very quickly. So any questions so far? Anyone? You can use questions tab to post your questions. And in case you don't have any questions, then we'll move forward. I'll just wait for a few seconds. Okay. No, I think you don't have any questions right now. Okay, we'll move to the fourth part. So this is going to complete our session on DP900, which is the fourth and the final part of DP900 or Azure Data Fundamentals. So in this module, we will learn about different large-scale analytics services that is provided by Microsoft Azure. We'll explore real-time analytics. What are the different services for real-time analytics? And we'll also explore a bit of data visualization. What are the different offerings by Azure, Microsoft Azure, right? In large scale analytics, we are going to discuss data warehousing. What's the architecture of data warehousing? How does data ingestion works? We'll discuss some of the pipelines of analytical systems. We'll explore platform as a service solutions for the large scale analytics. And we'll see what's the offering via Microsoft Fabric. So Fabric is something which is a new service, a unified platform which is now being offered by Microsoft Azure. And then under real-time analytics, we'll learn about batch processing, difference between batch and stream processing, common elements of stream processing. We'll see what's the services provided by Azure in terms of real-time analytics or near real-time analytics, right? And we'll take a look at Apache Spark, when how you can use Apache Spark on Microsoft Azure. And then you'll have to do certain exercises on Spark streaming. We'll explore real-time analytics using, and then at the end we'll cover Power BI tools and different visualizations. We'll see how different visualizations look like and what it means and when do we need to actually use those visualizations. Okay, so this is the architecture of data warehouse, right? So whenever you work with data warehouse, you just understand that this is basically used for analytical purpose. And whenever you use any database systems for analytical uh, uh, data model or creating analytical systems, then it is basically at the end you aggregate the data, right, based on certain dimensions so that it is easier to show the reports or generate the reports, and it is faster, right, so that you can quickly generate the reports based on certain uh, uh, filter criteria or based on certain dimensions or based on the pre-aggregated model that you have created. Okay, so there are four different steps in this architecture, right? So the first one is obviously you need to get the data from certain systems, right? In this case, your data may be in the format of files or your data may be stored in some database, right? DB storage. So either ways, the first step is always to get the data from the files or the source systems, right? So that's called ingestion. So whenever you try to fetch the data from different source systems, that's ingestion. The process may succeed or the process may fail. So failure case you'll have to handle. If it's successful, then obviously it's go to next stage. Okay, so that's what we understand by data ingestion. We get the data from data sources, and then after processing, we put it in the next page. We can store the process data, or even if we don't want to change anything for that piece, or let's say we are getting data from this file stores and we are following ELT, right? ELT is extract, load, and then transform, right? We first extract it and then we load it to some data lake and then we transform it. There are two variations in this case that depends on the use case of different organizations. So in some cases we use ETL, which is the old way of working with data, and nowadays the modern way of working with data is ELT, because we have cheaper storage systems, cheaper storages, right? We can store all the data that we have, so we don't transform it first before saving it to some kind of database. We just load it, right, or we just dump it to some kind of storage. So in this case it's data lake, where the raw data will be stored in data lake. Okay, and after processing, what do you do after you store it in data lake? You kind of process it, right, based on the requirement. So what's the final requirement? Final requirement is always to produce some kind of reports, right? Or whether it's business report or you visualize it and show it in dashboard via BI tools, or you generate some kind of reports for the users. right? That's the final thing that you want to work. So in order to generate reports in certain format, you need to process the data, right? Because there may be certain things which is not available, or you may need to change the format of data. You may need to calculate something. So all those things, all those calculations will happen in between, right? And whenever you work with data warehousing systems, then you aggregate. So after processing, you aggregate the data and then create an analytical model, right? In this case, you create when you create this analytical model, basically you aggregate certain based on certain criteria, right? Based on certain columns. Let's say you have data and then you want to filter out based on cities, or you want to filter based on year. So all those dimensions will be based on different dimensions, data will be aggregated, right? And we create an analytical model that's called cube, right? This is the format of the cube. These are different dimensions that we have aggregated the data, right? So this is called cube. And then the final step is data visualization, or generating reports based on the user requirement, right? Which is basically you may use it for your business to identify or show the trends, or for a business the main purpose is to track the performance, right? To track the performance indicator. So how the things are going on, whether the company is able to generate revenues, or how it is, right? So all those will be tracked via some indicators or the metrics, right? Those are known as key performance indicators. So there are certain metrics. So whenever you work with organizations, they want to track certain things. That's when business, or the upper management knows that whether our systems are working fine, or whether our business is booming or growing or not, right? Based on the metrics. Otherwise they won't be able to track it. So that's why we need a visualization which is very easy to understand whether our organization is going, I mean, we are progressing or not. Again, this is very similar, the pipelines that we see, right? So obviously the first step will always be this is the data pipeline, right? Even this is also the data pipeline, right? But this we particularly spoke about data warehouse, and in this case it's a normal data ingestion pipeline. We'll go in deep a bit. What's ingestion? So ingestion is nothing but getting data from different systems, right? It may be either files, or different services. So in that case you get data from different inputs, right? So input data goes to various activities. So whenever you get the input data, you transform it, right? So this is what a pipeline does. Pipeline orchestrate the ETL process, which is basically extract, transform, and load. In some cases it might be ELT as well: extract, load, and transform. So in order to achieve that extract, transform, and load, you will have to again get the data, right? You get the data from certain inputs or source systems, right? So whenever you work with data factory, so you kind of get option to create different activities. Let's say you have multiple source systems. You create all those sources, linked service for those systems sources, and then once you receive the data, once you have the input data, you perform activities on that. So if you need to transform it, or let's say you need to save it to different you need to save it to SQL database, then you will create some activity, and then after processing you will save it to SQL. If you again want to work further on the same data, or different, or after you want to work on the processed data, and create certain processing, or work on data bricks, right? So in this case again you can use the same data for your own purpose based on the requirement, whether you want to work with SQL, or again you need to process it. uh, and if the data is large enough, you'll obviously use Spark or data bricks. So based on the requirement, you'll use different services that Microsoft Azure offers. And finally what you will do is you will output it, you will save it somewhere, right? So you may also use Microsoft Fabric, which we are going to see in the coming slides, which is basically a unified workspace. In this Microsoft Fabric, you don't need to create separate services. everything is under a single platform, right? Under a single umbrella, you will have all the services, whether it's SQL, whether it's whatever the services that being offered as part of Synapse Analytics or Azure Factory. All those things are included in Microsoft Fabric. That we'll see in upcoming slides. So let's explore the differences between data warehouse and data lake house, right? We saw what is data lake, and then we'll also work with data lake house, which is lake house, a bit new term or a new concept, right? So we'll understand. We already saw data warehouse deals with analytical systems, but at the core, it's relational database, right? So data warehouse is nothing; it's kind of database, right? So whenever you work with database, you work with analytical systems, right? So data will always be optimized for read only because you need analytical systems are mainly built to generate reports or read the data many times and then you fetch the data from the systems. So that's why the schema is optimized for data analytics, which is basically for read only mode, right? And one thing to note down here is whenever you work with the data or data warehouse, one of the table will be known as fact table, right? Which is basically when you work with retail system and you get the bill, right? Bill will have the bill that you get from the retail system, or let's say when you go to supermarket, they will provide you the bill, right? Bill will have a number one, number two item list, right? You will have again the items and the number of uh, you will have quantity, right? What's the quantity for all those items that you have bought, and then price. So everything is inside a single format structure, right? That structure is known as fact table. So that's the fact, right? And the definition, or let's say you get a single bill from the supermarket, right? Product is also included, price is also included, and the quantity is also included, and then date part also is included. But in this case, you will have different dimensions. Those are called dimensions, right? You will have product data is also available in that bill, but you don't get the entire details, right? Product name or product family, all those things, right? You only see a couple of columns in your bill, right? Only the product type, or let's say product name, you will only see. So which is basically the product ID in this case. So whenever we work with data, so it's very important. If you're not able to visualize it, we'll see what's the difference between star schema and snowflake schema. But just understand that there is a structure such that you have a fact table, and then you will have different dimensions, right? Fact table in this case, let's just take the example of supermarket. You will have a bill, right? Bill will contain the facts. It will have product and then price and all, whatever the quantity and all, date, when did you buy those things. And then you will have separate tables for each, right? Let's say for products, you will have a product table, and then you will have separate customer details. You will have date or details, right? So all those things are formed in uh, uh, star structure, right? It forms a star structure, right? Multiple tables. In middle, it will be a fact table, and around this fact table, you will have different other dimension tables, right? So that's called star schema. And in fact, let's say for the product table, which is one of the dimension table, let's say we further subdivide it, right? Then it becomes something like snowflake schema, right? You might see the structure of snowflake. It gets further subdivided, right? It formats it's something like this, right? This way, and then again like this. So those format is known as snowflake schema. So we'll see the structure. What's the data lake? Data lake is nothing but it's kind of a distributed file system wherein you store different files in it, right? It's kind of folder based system, you can understand. Data lake house is combination of data lake, which is basically the file system, and then just remember this file system. Whenever you work with data lake, it's on distributed platform, right? You work with large distributed systems. So all file systems are distributed. So when you work with Lakehouse, it's combination of data lake, which is file system, and then data warehouse, right? So it will exhibit the property of lakehouse file system as well as relational database. So you can directly access the files. You can create a schema on top of the files directly. You don't need to save that files into some database, right? You don't need to process it and save it to database. You can directly access let's say row and column directly from the file based systems, right? So that's how data lakehouse works. It is supported by Synapse Analytics. So one of the services which is provided by Microsoft is Polybase. So Synapse Analytics also contains Spark, right? So Spark does support this lakehouse. Okay. Now we'll see different PaaS platform as a service solutions offered by Azure, right? These are the different platform as a service solutions. So one thing to note down here is you will see the importance of Spark here, right? So whenever you work with big data systems, you cannot ignore Spark, right? So even Microsoft Azure, three different services for Spark, particularly for Spark. So whenever you work with, so this Synapse Analytics is something which is owned by Microsoft and Azure. It's their own platform that they have built, right? Where you can create clusters of, you can create a Spark cluster. So it will again have Spark that you can access via Synapse Studio, right? So this Synapse Analytics is a unified end-to-end solution wherein inside the Synapse Analytics, whenever you create Synapse service, then you'll be able to access SQL Server, you'll be able to access Spark, you will be able to access Data Explorer. So all things are unified within a single platform, which is known as Synapse Analytics. And also whatever the pipelines that we see in Data Factory, right? That's also available as part of Synapse Analytics. Azure Databricks you might be already aware of. If you are not aware of Databricks, so Databricks is a platform, again, unified platform. Databricks is another company, right, which provides, they are basically the founders of Spark. So they created this company Databricks, and Azure is something that they coordinated with Databricks, and then they had a contract. Then they combine the services of Databricks with Azure, and this combined service is known as Azure Databricks, which is basically you get the services of Databricks. As so when you use the Databricks in Azure, the benefit is you get to use Databricks services, which is Spark, Cloud Spark, and then on top of that you can use all the services which are being offered by Azure Microsoft, right, as part of the Azure platform or the cloud platform. So you have access to AI tools, you have access to machine learning tools, and all the other let's say storage part as well, right, apart from what Databricks offers. And the main benefit of using Databricks is being offered through different cloud vendors as well. So AWS also offers Databricks, GCP also offers Databricks, and in fact, Databricks is a separate company, so obviously they offer Databricks services. So even if you have worked with any of these Databricks solution, right, provided by these companies, you will have the same services in multiple or different cloud systems. So you don't see any difference in that. The only difference will be if you are using Azure Databricks, you will have the Azure services as the extra things that you get. If you're working with AWS Databricks, then AWS related components or the services you get as something extra to work with. Similarly, for GCP, you will have some GCP services apart from the Databricks. So it is very portable, right? If you are using Databricks and you're not liking the Azure services, you can move to a different other vendor, right? You can move to GCP, you can move to AWS, or in fact, if you are just using Databricks and you're not using Azure services, you can move to Databricks as well. So what Databricks offer? It offers a notebook, right? So a Spark in Databricks, you have option to create Python notebook, which is basically Jupyter notebook, right? So it's an interactive notebook where you can create or you can put your logic based on different languages. You can use R, you can use Python, you can use Scala, or you can even use SQL syntax, right, for that purpose. What is Azure SD Insight? Azure SD Insight is nothing but the combination of all the big data systems or all the big data technologies into a single platform, which is basically all, it combines all the open source technologies, right from Spark or Hadoop, all those things, right? All those are included inside Azure SD Insight. So whenever your organization work with different open source technologies, big data technologies, and you want to move from on premises from organizations, right? Now, you don't want to take care of the backend infrastructure, let's say hardware part or operating systems. Let's say you have Linux systems to take care of where you have installed Hadoop solution, or you have installed Spark, right? And now you want to move to cloud. So in this case, you can create similar services in Azure Insight. You don't need to start from creating or start from getting hardware. You just directly create your services under SD Insight, wherein you don't need to maintain the infrastructure or the operating systems. So this was all about analytics. Okay, and the last one that we'll see as part of analytics is Microsoft Fabric. So Microsoft Fabric is again the unified service. So whatever the services that we saw right now, let's say these things, right? You work with Azure SQL, Synapse Analytics. Again, you will have Spark. We also saw Databricks, right? You also saw Data Factory, and then we also covered storage part, DataLake Gen 2, and all those things, right? So all those services will be combined into a single product, and that product is known as Microsoft Fabric. So why they have created this fabric? Because it is very easier for any organization that they will just create a single service, which is Microsoft Fabric. It will provide you a workspace. You don't need to create separate services for each of the multiple things or the separate services that you create for it. Let's say you create separate storage again for uh, transformation. You use data factory, so you create data factory services. uh, let's say you work on big data and you again need to process the data, all those larger files, and based on the logic you want to process and work on distributed system, then you use Databricks or Spark. So everything is combined, right? You don't need to create separate services. So it's easier for organization or big organization who can pay that charge, and then they can use a single product instead of using multiple, instead of creating multiple services, which is complex to handle or complex to take care of, right? So it's very easy that you go to a single place and you can access all those offerings from Microsoft. And where the data is stored, so they have created something called One Lake, which is basically a storage for storing all those uh, files and all backend files. So all those get stored in One Lake. Okay, so that's all about that's what you need to understand about Microsoft Fabric. This is a small exercise you do. Microsoft Fabric, I don't think you will be able to do, but even if you are not able to do it, just go through the steps that are required to complete this Microsoft Fabric exercise. Basically DP 900 will not ask you any practical aspects of it. It's just about understanding different offerings of Azure data services, and what you can achieve, right? In what scenarios you will use those services. So if you have that understanding, then I think you are good to go. And then we'll understand the difference between batch processing and stream processing, right? So there are two kinds of data processing that we work with. One is batch processing, where data comes in batches. It gets stored at particular, let's say in table or in a file, and then we process the file, right? That's batch processing. We combine all those different files into a single unit, and then we process it in a single scheduled job or so. What's the stream processing? So stream processing works in such a fashion that it needs to process the data and as and when it comes, right? So let's say now I have received two records, then I'll process the two records. If I received four records, I'll process the four records. So in real time I need to process it. But how the batch processing works is, even if I receive two records or four records, I'm not going to process it right now, right? I will process it all together in a single batch, right? I'll collate all those data which is required to be processed, because there might be certain dependency. So the requirement for both batch processing and stream processing is different, right? In batch processing, you run a job, you combine all the data that you have received so far, and then run the job at certain schedule required by your organization. Stream processing, you process the file or the data, right, as and when it comes. So in stream processing, it might be in on real time, or it may be near real time, right? There may be certain lags in processing the data. That's called near real time processing. So this is what we have already covered, batch processing and stream processing. Let's look at the advantages and disadvantages, right? I will not say it's advantage of batch processing or disadvantage of processing, but this is how batch processing works, right? This is how it is meant to be. So there is nothing advantages or disadvantages. If you need to process the large chunks of data, if there is a need for your organization to combine all the files and process them, because there are dependencies between each of the rows, right? Or you want to process them at a single time. Let's say whenever uh, you might have credit cards, right? Or even if you may have bank accounts. So on a monthly basis, you get credit card bill, right? You don't get bill on daily basis. So it collates all the data, right? It combines all the data that you have, all the transactions that you have performed for that particular month, and then it generates the monthly report and it sends it to you, right? So that's the example of batch processing. It combines all the data and it schedule, I mean, at certain time, it will process all the data and send it to you. That's how it works, right? So there is nothing advantages or disadvantages, but it's the term that they have used, like advantage and disadvantage. But in the real world, whenever we work with organizations, so it's not the disadvantage. This is how it is meant to be. This is how we use the batch processing. In case the data needs to be processed as and when we receive the data, then it's called different thing. It's real time, right? That's how it process the data. So if we receive this too, because we want to show it in real time, let's say election result, right? So you don't wait for the entire result, right? As and when you receive the vote result, let's say one while counting the vote, I just saw that, let's say one vote we saw for BJP, and then one vote for Congress. Then as and when we receive, or we get to know the count of each vote for different parties, then we show it, right? That's how the stream processing works. It's similar to that. So in fact, it's a good example, right? Election results are the good example of stream processing. So as and when the result comes out, and we get to know about the result at that particular time, whether who is losing or who is winning, right? So it's real time processing of the data. So these are the difference between batch processing and stream processing. It processes all the data. So we have already discussed all these things. Batch processing, it processes all the data in the data set. Stream processing, it processes the recent data, right? It will have, obviously, when we collect the data, it's large data sets. In this, it's just micro batches. Performance, obviously, when we try to collect all the data, it will have latency, right? It may take few hours to process it, because we have huge data, right? We are working on huge data, we're trying to process the huge data. So hence perform, it might uh, give you it might have higher latency, it might take few hours to process. In stream processing, it's just very smaller chunks, right? So you can process those records in milliseconds, or seconds. Analysis, so it's being used in complex analytics. And stream processing, it's simple average kind of calculations, or aggregations that you use, right? So that's how you use stream processing data. This is one of the services offered by Azure, which is basically stream processing, right? So this is one of you can see this is the architecture, how the stream processing works. Okay, it may be mix of batch processing and stream processing. So in this case, we are trying to combine the batch processing along with stream processing. Let's say The top one is stream processing and the bottom one is batch processing. So how it works is we get data from stream processing in the real time, right? So let's say 2 records or 4 records. So as and when we receive the data, we may store it in some files also, right? So apart from taking it further and processing it, then running some kind of transformations on it, if our need is to save the data, we can save it in file store. So we will save the data, and also at the same time we process it and generate the report in real time after processing. And after processing also, we store it somewhere, right? We store it in database, we store it in data warehouse, and we can either uh, visualize the data or we can generate the report, whatever the requirement, based on the requirement. So the first step and the last step is always common, right? First step is always about getting data from different systems, and the last step is always about uh, showing trends, data visualization. It's always about reports, right? And in between these two, data ingestion and data or visualization, we have data processing, right? Processing is storing the data somewhere in the file system or data lake, and then running the processing part on it, and then we'll again store the processed data in data warehouse. It will be in the form, if we are working with analytical systems, then it's pre-aggregated, or we create analytical model or the cube, right, that we saw in earlier slides. So this is common elements of stream processing. So here you need to understand that there is an offering from Microsoft Azure. So again, the first step, which is getting data from different sources, data ingestion, right? Last step is again the same. It's visualization. So it's very easy to understand all the whatever the architecture is, right, in the big data systems. The first step will always be getting data from different systems, whether it is real time source, or whether it is getting data from file systems or getting data from DB or so, right? And in this case, when we work with the stream processing, the architecture is it uses some kind of queue. So we need to process the data, and as when we receive the data, right? So it forms a queue and it processes it based on the queue. In this case, we may use Kafka as well, which is basically used for stream processing. Okay, and then we can save it in, we can process it, we can run certain aggregations, or we can run transformations, and then we will save it in analytical stores, or we may use it to visualize the data. Okay, so the end result may be either we can save it, if we are saving it in some file systems or storage, it's called sync, right? Sync is nothing where you just put all your output to, right? You just dump it and then save it somewhere, so that's called sync, right? So this is one of the services offered by Azure. It is very similar to what we saw. The first step will be getting data. So whenever we talk about stream analytics, right, so the first step will always be getting data from streaming systems, right? So there are various streaming systems in Azure. Let's say there is Event Hub or Azure IoT, right? In case you are working with internet-based systems, so IoT systems, so you will have Azure IoT to handle such cases, and it will generate data. The only thing is the processing part, right? The processing part is based on a query, right? So it has got, so stream analytics, how it works is you create some kind of query based on the data that you receive, which is basically used to aggregate the data. And if you need to further process it, whether you are using Synapse Analytics or SQL and all, you can do it. But you just need to remember the mid part here, right? In Azure Stream Analytics. So you have option to run query, which is basically similar to select statements. And the end result you can always write it to based on your requirement. You can store it to SQL, you can store it to Synapse Analytics, or you can store it to Fabrics, and whatever you can visualize it, or again you can put it back to IoT Hub or Event Hub, right? So this is all about Stream Analytics. Again, you go to this Stream Analytics lab and you can complete it. This is very similar. This is let's cover this today itself. So can I continue? I think we'll be able to cover it in next uh, 10 minutes. We'll be able to cover it. Any comments? Can I continue? Because then we'll be able to cover it fully today. Okay, I'll just continue. I'll cover it quickly. Okay, so now we'll look at Apache Spark on Microsoft Azure, how the structured streaming takes place. So if you are using Spark for streaming purpose, then there is something called the structured streaming, right? That's one of the components of Apache Spark. So you need to use structured streaming library whenever you work with streaming data, right? You need to remember this structured Spark structured library that you use if you work with streaming data, right? So it provides kind of API for that particular purpose, wherein you can get the data from upstream or different sources. You will process the data, and again you will put it to some tables or the results, right? So how do you process the data in Spark? So there is something called data frame. So whenever you get data from upstream, you create a data frame, right, which is basically similar to tables. So this data frame is different from this Spark data frame is different from what you see in common Python data frame, right, or pandas data frame. That's different. So in this case, it's called Spark data frame. As and when you receive the data and you create this structured streaming, so when you process the data, it gets stored to data frame, right? Again, when you receive the data, so it's a continuous process. It just keep getting stored in that particular data frame, right? You don't need to run it explicitly. So it keeps on continuous basis. It will run that job, right? That's how it takes care of the streaming data. What is data lake? Data lake is again unified this batch processing as well as stream processing, which is delta lake is basically it supports Spark related processing. So it has benefit of common data warehouse as well as data lake storage, right? So it has got the benefits of uh, uh, data warehousing as well as it has got storage part as well. So that's how delta lake works. So since it works with Spark supports this delta lake, then obviously there are two services or three services in Azure which offers the support for Spark, but the main two services are Azure Synapse Analytics and Azure Databricks. And so obviously it will support Delta Lake. Okay, and you can work with both batch processing as well stream processing in case of Delta Lake. Okay, so this is again Microsoft Fabric, which is basically the similar thing that we saw. Right, so Fabric is combination of services that we saw till now, right? So when we talk about streaming data, then obviously we are talking about Azure Stream, right? So in this case, we will have event stream. Microsoft Fabric provides something called event stream. So when you get data from streaming systems, it's kind of a queue. You get it in event streaming, and after processing, you may either put it in like a lakehouse table or you can put it in database table. In this case, you can create table on KQL, which is custom query language, and when you save those records in database table, you can access it via KQL, which is custom query language. So that's what you need to understand. This is how the Microsoft Fabric works, and that's provide the support for real-time analytics, and it will be able to ingest data from real-time sources, right? Multiple streaming systems, and after processing it, you will be able to save it in lakehouse or you can save it in different database, and again you can access the records via KQL, which is a different query language, which is custom query language. Okay, so now comes the final part, which is data visualization. So if you come from analytics background, or analysis background, data analysis background, and if you aspire to become data analyst and even data scientist, then more often you work with data visualization part. So you might have heard about Tableau and other visualizations tool, or let's say Looker from Google. In this case, Microsoft offers one of the services or the tools for visualization, which is known as Power BI. And using Power BI, you will be able to create powerful visualizations, right? Uh, Very beautiful visualizations you'll be able to create. Why do we need visualizations, right? We need visualization so that users are able to understand the crisp data very easily without going through the entire set of tables or multiple rows, right? So they can understand about the data. They can directly see the trends, whether we are progressing towards certain things or whether we are lacking something, right? So all those things can be visualized using Power BI. So again, when you work with analytical systems, we already saw that we create analytical model, right? Analytical model, it means it's pre-aggregated value, right? We aggregate data by dimensions. So let's say when we aggregate the data with different dimensions, in this case, this axis is product, this axis is time, and then by customer. So there are different dimensions, right? When we aggregate the data using different dimensions, it's called analytical model. So we create analytical model out of it. So one of the option we have in Microsoft BI is we can create data model out of the data that we are going to receive from upstream, or we uh, load file based rows. Let's say we are if you're working with CSV or some delimiter file, you will directly be able to load it in Microsoft BI, and then you can create data model out of it. Okay, how does this work? This is how you create tables, right? What is data model? You will have one fact table, right? This is what I was talking about. You will have one fact table, which is basically, let's say if you work with a retail system, you will have a fact table, right, where you will have key and value, and then what all products did you buy, what's the quantity, what was the price of that uh, product, right? So all those things will be saved in a fact table, and then you will have different dimensions surrounding this fact table. So this forms a star shaped format, right? That's when you call it star schema. And when this further gets subdivided, then let's say we subdivide it into customer, let's say address and the name and name details, first name, last name, or middle name, address, right? So when you further subdivide these tables, then it forms snowflake schema, right? So that's the difference between. I just want to highlight it again so that you are able to visualize it. Visualization is very powerful, right? You don't forget what you learn using visualization. So this is how it's forming like star, right? Hence it is known as star schema. So you will have one fact table and then different dimensions. So whenever you aggregate values based on customer or based on time or based on different dimensions or the product in this case, right? That's how we create data model, right? In this case, it's pre-aggregated value that we create, right? Data model is nothing but we create a pre-aggregated, or we aggregate the values based on certain parameters. So in this case, if we want to fetch the data based for a particular year, then obviously you have already aggregated it for particular year. For 2022 we have aggregated all the data. Let's say I want to fetch the data for a particular month. Again, for January we have already aggregated the data. Let's say for particular day we want to fetch the data. So these kind of aggregations you create a model such that data gets aggregated based on different dimensions, right? That's called data modeling. So this is how we create data modeling. So this is Power BI desktop, okay, and you will get data from different tables. You will in fact join these tables Okay, and then you will create different aggregations, right? In this case you are trying to aggregate the data based on customer, based on product, based on time. So all those aggregations you will have to create it here, right? So that's the model. That's how you create the model in Power BI, right? You have one main table, one fact table, and then you relate it with different dimension tables, and then you aggregate the data, right? So if you're able to see this, I'll just this, right? So we are trying to aggregate the data based on product key, based on quantity, revenue, and all those, right? So we have fact table, which is sales, we have dimension, which is customer, times, and product. So this is what data model is. And then we'll see different data visualizations, right? So these are the different formats whenever you work whenever you try to analyze, whenever you analyze the data. And if you are analyst already, if you are data scientist, then most of the times you work with visualizations, because you need to show the visualizations or the trends, right? You uh, work on the data and then try to find the trends and show it to the users or the customers. So these visualizations are very important to understand. In all the scenarios, we don't want to create a single kind of visualization, or let's say chart, but different formats have different importance, right? Because in everything, I mean, we just if we just create tables and text, it doesn't make sense to use a single format, right? If it's easier to understand some other format, then better we create uh, or we combine the table, or we create that visualization, that type of visualization, right? So there are different types of visualizations that we'll learn in this slides. So the first one is bar and column chart. So in what scenarios do we need this bar and column chart? So whenever we want to show the combined result, or let's say a category, right? If you want to show the result based on certain category or categorize the data, let's say I want to show the revenue of a certain product for different cities. So in this case, you will have to use bar and column chart. That's the best to use. So we are easily able to visualize. It's very intuitive, right? So Seattle in this case has got revenue of in between $200 or $100. Let's say $170. New York City has $100 docents. It's very easy to visualize. So when you work with different categories and try to visualize it, it's better to use bar and column charts. In certain scenarios, tables and text are more important, right? So if it's a tiny table, then you will use the table directly, and it's also a single. Just if you just want to talk about just the revenue, right? Just one number, right? Then you can directly use the text like dollar 302, something like you can use in that scenarios whenever you just want to highlight single number, or a single category, right? So in this case, you will be using tables or text. Again, now we'll look at line charts and pie charts. So these are the two different things. So the top one you see is line chart, and the bottom one is pie charts. When do you use the line chart? Line chart is used to show the trends, right? It shows whether the revenue is increasing or decreasing. It shows the trend whether you are losing customer or you are gaining customers, right? So it's very easy to identify, right? So we can see this plot, right? It's going down, that means we are losing. Again, it's going up, that means we are gaining, right? So that's how it works. So this, in case you want to show or show the trends, then definitely you would like to use this line charts. And if you want to show the percentage, or if you want to show certain divisions, right? Let's say 70% of the people are have been categorized like this, and 30% people have been categorized like this, or let's say 30% of the tools like this, and 70% like this. So if you want to segregate the data based on certain categories and want to get a picture of that, right? Then that division can be done by pie charts. So it's very easy to identify what percentage, or what chunk of data belongs to a particular category, right? In this case, let's say tools, apps tools here indicate 66%, 66.67, and then hardware indicates 33.33%. So it's very easy to visualize this. And then scatter plots and maps. What is scatter plot? So whenever you want to show the relationship between two variables, then scatter plot comes to the rescue, right? You use this scatter plot and it shows the relationship between two, right? So when you increase your marketing, when you put dollars, when you throw money on marketing, then obviously your revenue is going up, right? That means there is a direct relationship between marketing and revenue. So look how easy it is to show the relationship between these two, right? Revenue and marketing. So we can show it via scatter plots. Maps, again, when you are trying to visualize based on states or the city, trying to visualize certain things based on the city or state, then obviously you'll use a map. Let's say you want to get the revenue of a particular city. Let's say in India, I want to get the revenue of, or total GDP for Hyderabad or Delhi and all. So obviously use these maps, right? That's easy to uh, visualize. And then we can combine all the reports that we have learned. We can combine all the formats of data visualization into a single report or the dashboard, right? That option we have in Microsoft Power BI. So whenever you use different visualizations in a single dashboard, and you have option to filter on, right? So let's say if you select a particular city, then all these visualizations gets filtered based on that particular selected city, right? Let's say in case you selected here Bangalore, then whatever the data that you see here, it will automatically filter out the result for Bangalore, and it will show you the sales report or the revenue by month, product sales, quantity, sales by city and category based on your selected city, right? That's all. So this is known as interactive reports, right? Because you are selecting, you are interacting with the reports, hence it's called interactive reports, because you are able to select city, right? Based on the city, it gets filtered automatically. So that's how it works. So yeah, that's all about DP900. Now we have covered it all, and yeah, if you have any questions, then you may ask. And now you are ready to crack DP900, and I am sure you'll be able to crack it with each. It's not difficult. You can again go through the resources that I have provided, and you will be able to crack it very easily. Any questions so far? So we'll wrap up the course. I'll just wait for certain questions if you have. Otherwise, we'll wrap it up. Any questions? Okay, we'll close the session. Thank you guys. Thanks for staying here on the Sunday night. I can understand, but it shows your motivation, and definitely you're going to crack this DP900. And you might have learned about, even if you're not trying to crack this DP900, you definitely got the understanding of different services provided by Azure related to data, right? So all the best. Thank you. Thanks again. We'll close the session.